All right, physicists, here we go with number 8. Number 8 tells us that an elastic-loaded balloon launcher, whatever that is, fires balloons at an angle of 38 degrees north of east from the surface of the ground. If the initial velocity is 25 meters per second, we want to find how far away the balloons are from the launcher when they hit level ground again. I frankly think this problem is dumb and weird, but we're going to solve it anyway because we can. All right, so for number 8, let's set up what we know. Let's set up our x and y's. We know as per usual that a is 0 in the x direction and negative 9.8, assuming we're on planet Earth. Now, it doesn't say that we are, but it doesn't say that we're not. And 99% of the time in this class, we will be solving problems on Earth. So we can go from there. Now, we also know that the balloons are fired at an angle north of east. That angle is 38 degrees. And the velocity with which the balloons are fired is 25 meters per second. So my first step, like my first step in number 7, and like my first step in number 6, are to figure out what exactly my x and y components of this are. So to figure out my y component, I'll have 25 times the sine of 38 degrees. And my x component is going to be 25 times the cosine of 38 degrees. Using my calculator in degree mode, I know that my x component is 19.7 meters per second, and my y component is 15.39 meters per second. And I can go from there. So let me put these values in here. 19.7 is my x initial and final velocity because acceleration is 0. My initial y velocity is 15.39. And then let's see if I know anything else. Well, it says that the balloons are fired from the ground and they hit level ground. So yet again, from ground to ground gives me 0 as my delta y. We're going to have the same approach as we did on the last one. We're actually going to solve for time first to figure out delta x. So, using our oh-so-friendly delta y equation of VIT plus 1/2 AT squared, we know that delta y is 0. We know our initial y, then we have to use the y values here. Velocity is 15.39 t. Plus 1/2 times negative 9.8 times t squared. That gets me to a quadratic equation. Again, you can solve this graphing or with the quadratic equation, however you would like to. My favorite method, yet again, is graphing. And when I do that and throw out the non-physical answer, I get 3.14 seconds of my time. Then my final step is just to plug that into my delta x equation to figure out my range, or how far from where they were launched. So I need to use my x velocity, which is 19.7, times my newly found time of 3.14, which gives me 61.86 meters.